Good afternoon, everybody. So, welcome you all again for the second session in the lecture series Non-Sewer Sanitation, brought to you by NIUA, National Institute of Urban Affairs, and Ecosan Services Foundation. So, this lecture series is going to have 4 sessions. We did the first one on 22nd May, which was on sanitation planning. Today's session is on sanitation system approach. The next 2 sessions which we'll be having in this lecture series are liquid waste management and then fecal sludge and septage management. So to recap the first session of sanitation planning, in the first session, we saw that there are numerous urban challenges when it comes to sanitation planning. One of the 2 challenges which most of the urban local bodies face is that of professional capacity to plan and execute the plan or the systems. And secondly, the management gap. That is the professionals which are required to run the systems or the financial aid which is required to run these systems. Then we saw a concept of environmental health, which holistically takes into consideration not just human health, but also the health of the natural environment around us. And for maintaining the equilibrium between the natural environment and the built environment, we saw that we need 4 different kinds of environmental services. That is water supply, then sanitation, solid waste management, and stormwater management. After that, we saw how environmental sanitation promotes social development instead of just designing infrastructure projects and executing them. Hence, we are prioritizing the quality of life when we take environmental sanitation as one of the approach. In the last session, we also saw how the waste streams are segregated based on their characteristics. We saw majorly types of wastewater, which is brown water, gray water, black water, and then domestic wastewater. And then we saw there are different processes and management steps which are involved to manage these different waste streams. The processes which are involved are basically user interface, collection and conveyance, treatment, and reuse or disposal. Whereas management consists of financial aspects, planning aspects, operation and maintenance of the systems. Today, we are going to take a look at an approach towards sanitation planning called sanitation system approach. In this session, we are going to see different kinds of sanitation systems. We are going to see examples of one of this type of system, that is dry sanitation system. Then we'll deep dive into wet sanitation systems, which is mostly prevalent in most of the industrialized countries and also Asian countries. And then lastly, we'll be taking a look at 2 case studies, 2 very different case studies, but having a very similar output, that is wastewater treatment. So the objective of today's session is to make you or familiarize you with the sanitation system approach and discuss different technologies which are involved in these systems. This approach not only helps to during the sanitation planning, but even to understand the ground situation, to assess the situation, to find the gaps, and then to identify the correct solution for the sanitation system or for taking care of the human excreta. So to start with sanitation system, the definition of sanitation system is to take care of human excreta and wastewater from the point of generation to the point of reuse or disposal. And during this complete process, there should be minimal human intervention. The objectives of sanitation system is basically in line with environmental sanitation, that is to protect and promote health as well as the environment. Then it should also be simple and straightforward in terms of technology. The most important is the affordability of the system. The whole system should be affordable and in such a way that it can be operated and maintained throughout its life. The next approach or the next objective is it should be culturally acceptable. Different cultures demand different types of user interfaces, which is one of the functional group in the sanitation systems, and hence the systems which you are thinking about should be culturally acceptable. And last but not the least, it should work for everyone. That is, it should work for the lower income groups, the middle income groups, and also the higher income groups. On the screen, you can see different types of sanitation systems. Sanitation systems are basically divided into two types, that is wet systems and dry systems. Simply to put in word, wet systems means the systems which requires water for flushing the human excreta. And dry systems is where no water is required. We'll be looking into wet systems in detail. So let's now focus on dry systems. Dry systems usually consist of three types, that is cartage, drop and store, or dry toilets. Let's take a look into the dry sanitation systems. On the screen, you can see there are two prototypes or two types of dry sanitation. That is a bucket latrine and a pit latrine. So you can see a bucket latrine is simply a bucket which has a seat, sort of a toilet seat on top of it. And in this bucket, there is a plastic bag which holds all the fecal matter and all the dry cleansing material in the bag. And it is easy to just pick up the bag, wrap it up, and then give it to the person who has come for picking up the waste, and then simply replace the old bag with a new bag. So these type of bucket latrines are quite famous or used in African countries where there is lack of water resources. Also, these bucket latrines are quite popular in slums where not enough space is available to set up a individual toilet for each household. On the left hand side, you can see a simple pit latrine where there is a closed lined pit under the seat where the fecal matter drops and is stored. Such pit latrines need to be emptied after a few weeks or after a few months, depending on the usage. Next is urine diversion toilet. There are three pictures you can see on this slide. The first two pictures are termed as dehydration toilets. So they don't only divert the urine or segregate the urine, but they also segregate the fecal matter and dehydrate the fecal matter to convert it into a compost sort of material. On the third picture is a flush toilet. It diverts the urine and it flushes with the help of water the fecal matter out of the toilet bowl. So urine diversion toilets basically helps to segregate urine and also the fecal matter with or without water. Urine, as we have seen in the first session, is concentrated in nutrients, and hence it can be reused into agriculture after safe processing. A typical urine diversion dehydration toilet looks like this. It has a seat and it has two vaults under the seat. So when the one vault is completely filled, the user starts using the second vault. Here, the fecal matter which is dropped into the vault has to be mixed with dehydrating agent like fly ash or wood chips or sawdust or even soil. What happens is over a period of time, the fecal matter, it dries out completely and it gets converted into something called human compost or humanure. Urine, which is also segregated using this toilet, can be stored into jerry cans, and then after undergoing a sanitization process, which lasts for 3 months, the urine can be applied into agriculture field. The cost of urine diversion dehydration toilet is relatively high as compared to pit latrine or bucket toilet, because there are two vaults and there is a requirement of two seats. So the area requirement is also high, as well as the superstructure, whose function is to provide a safe enclosure for the user. The cost of it also goes high. Next is a very recent innovation called Tiger Toilet. Tiger Toilet basically the superstructure looks very similar to a pore flush toilet, but what changes is beneath the superstructure there is a vault which contains vermicompost, and also in this compost there are worms which are known as tiger worms. So when the user flushes the toilet, or even without water, when the fecal matter drops into the vault, the solids they are retained on the surface of the compost where it is degraded by these tiger worms, and the water percolates through the drainage layer into the ground. So as soon as the fecal matter drops, the process of degradation starts. Timely emptying of these compost is needed, and it depends on the usage. The compost can be emptied after few months. The cost of this toilet is lesser than UDDT, and hence this is more popular toilet nowadays. This tiger toilet has been used in India as well as it is more famous in Bangladesh. Oxfam is one of the agencies who is promoting tiger toilets and implementing them across Bangladesh. So now that we saw dry sanitation system, we saw that dry sanitation systems are quite simple in terms of approach. But when we move to wet sanitation systems, there are different functional groups. So function is the term which is used for all the kinds of units which function in the same way. For example, different kinds of toilet. So these different types of toilets is termed as user interface. These functional groups have been clubbed together to form a sanitation systems. In the further slides, we'll see how these systems look like. On the screen, you can see 5 functional groups, starting with user interface, where the waste products are introduced into the system. Second is the containment unit, for example, like a septic tank. Third is collection and conveyance, where the solids as well as the water is collected and conveyed to a treatment unit, which forms the 4th functional group. After treatment, whatever the treated products or end products are there, they are reused or disposed in the 5th functional group. So you see these green arrows denote the way in which the waste products can travel throughout the system. Now let's take a look at wet sanitation systems. Wet sanitation systems are quite popular in South Asian countries and also in industrialized countries. Mainly the countries where water is abundantly available, wet sanitation systems are prevalent. Wet sanitation systems can be divided into 2 categories, that is seaward and non-seaward. Let's first see what does seaward sanitation mean. Seaward sanitation mainly consists of off-site disposal, which needs sewerage and wastewater treatment plant. So all the solids and the liquids, they mix together. They are collected and conveyed through sewerage, then they are treated in an STP, and then they are disposed off-site, that is away from the household. Whereas when you see non-seaward sanitation, it mainly means on-site disposal, wherein the household uses the toilet and the liquid waste goes into a tank like septic tank or soak pits, and then the treated product and then the complete treatment happens there itself. So there is no requirement of collection and conveyance in this case for the liquid effluent. However, in India, we see that there is a thin line between seaward and non-seaward, and hence we have hybrid systems. In hybrid systems, what happens is the households, they have a septic tank where the solids or the sludge gets settled, and which is also known as septage. And the sludge, that is effluent of the septic tank, it is put out by the household into the stormwater drains or the drains which run along the roadways. Uh, since the effluent of this septic tank is not managed at the household level, this system is known as hybrid system, and hence there is a requirement of collection and conveyance in this case. In this session, we'll be taking a look at 4 functional groups in wet sanitation systems. The 4 functional groups which arrive before the treatment. The first is user interface, second containment, third conveyance, last collection and transport, which mainly looks at collection and transport of septage or fecal sludge. The user interface is mainly the unit which is used where which is used, and the waste products are introduced in the system, such as flush toilets or vacuum toilets. On the screen, you can see there are different types of user interfaces in sanitation systems. It can be flush toilets, it can be Ecosan toilet or UDDT. It can be low flush toilet, as these toilets are used in at airports or in hotels nowadays. Vacuum toilets, which are mostly in India at least seen in aeroplanes, but in other developed countries they are used for even communities. For example, the World Islands in Dubai, they have complete system, sanitation system based on vacuum. So they use vacuum toilets there. Also, a simple thing like urinal can also be termed as a user interface, because this user interface brings in the urine into the system. Now let's take a look at a type of flush toilet which is known as pore flush toilet. Pore flush toilets, in the first session we saw, the pore flush toilets were introduced in late 19th century. The S trap, which is still being used, was exactly invented in 1750. The S trap was invented for the purpose, because these flush toilets, the odor was a nuisance. Whenever excreta gets mixed with excreta and urine gets mixed with water, it produces a lot of odor. So this S trap, which has a water seal integrated into the pan, the water seal helps to minimize the odor into the toilet. So it enhances the user experience. Also, the flush toilets nowadays do have a very low capital cost, because these pans are produced in mass quantities. There are different materials which are used to make these pans. Mostly it is ceramic, but in order to lower the cost of these pans and make them more affordable in case of rural context, plastic or even fiber reinforced plastic pans are nowadays used. The next is system flush toilet, where we have integrated a tank in order to flush the toilet. So this kind of toilet was invented in early 19th century, where the ball cock or a ball valve was used in order to maintain the level of water into this cistern, and discharge at a pull of a lever, discharge a fixed volume of water, which is around 8 to 12 liters of water into the water closet pan, and hence flushing the whole system and replacing the water seal with the fresh new water for the next user. Nowadays, we do have a low flush toilets which only consume 4 to 6 liters of water per flush. Moving on, we have collection and storage storage as a functional group. Here we have several options ranging from twin pits or leach pits, or the dehydration vault, jerry cans, which are used in case of UDTs for storing urine, or a simple septic tank. The twin pit units are linked to a pore flush or a cistern flush toilet. Here we have two pits where the fecal matter is mixed with water and is flushed down into the pit. When the one pit fills up, the seal is opened and the fecal matter or black water is allowed to drain into the other empty pit. During a course of months, the content of the first pit gets decomposed completely and converts into humanure. Whereas by the time the second pit fills, the user has to empty the first pit. It can be simply emptied using a spade, because in this case, the material is now completely treated and there are very less pathogens there. So it can be manually emptied using spade with minimum requirement of personal protective equipment. On this slide, you can also see a prefabricated lich pit, which are designed and now installed in a lot of places to ease or to expedite the process of constructing lich pits. The second option, which is mostly common and very much used in urban India, is septic tank. Septic tank provides primary treatment. Primary treatment in the form of sedimentation and biological decomposition of the settled solids. So when the wastewater enters or black water enters the septic tank, in the very first chamber, sedimentation process occurs. The solids which are heavier than water settle down, and the scum or oil, fat, and grease, which is lighter than water, they float on top. The clear water goes into the second vault where the same process continues, and then the water exits through this T pipe. The function of T pipe at the inlet and outlet um, is to allow the incoming water the function of the T pipe is not to disturb the scum and the sludge and allow the incoming water to get introduced in the central part of the septic tank. The septic tanks are designed in such a way that the sludge retention time is from 2 to 3 years. And in these 2 to 3 years, complete decomposition happens of the sludge. Now, from the septic tank, there is a liquid effluent which comes out. Or in sewered sanitation, the black water or domestic wastewater needs to be collected and conveyed. And hence, we have different types of sewerage systems or different components used in sewerage systems. The conventional sewers, which used to convey not just the domestic wastewater but also storm water during monsoon season, they are known as conventional sewers. However, now CPHEO manuals stresses upon the use of separate sewers, that is different sewers for conveying the domestic wastewater and different sewers for conveying the storm water. Simplified sewers are mostly used in slum areas where there is lack of space for implementing separate sewers. Small bore sewers are mostly used in conjunction with intercepting tank. To collect and convey the solids which are trapped on site in a septic tank or any other form of containment system, we do need motorized emptying and transport. We'll be looking at few examples further in this session. So let's take a look at how gravity sewers work. So in gravity sewers, all the kinds of properties, the households, the commercial properties, or even high-rise buildings, which produce different characteristic of wastewater, everything is mixed and it is conveyed in a common pipe. As soon as the depth of this pipe reaches 6 meters, there is a requirement of having a sewage pumping station. The sewage pumping station lifts the wastewater from the bottom of the station to the top. And again, this cycle continues. So sewage pumping station has a very high capital as well as operational cost and is an integral part of gravity sewers. Let's look how solid-free sewers are different from the gravity sewers. Although gravity is used here to convey the water, each property has its own septic tanks. What a septic tank does it traps all the solids and allows only the liquid to flow out. The liquid, since this is not containing any solids, can be conveyed larger distances with a smaller gradient. And hence we can cater to large number of properties without a need of a pumping station. Solid-free sewers are relatively easy to operate and maintain, and since they are laid at a shallow depth, the capital cost of solid-free sewers is significantly less as compared to gravity sewers. So now moving towards the collection and conveyance for solids, we usually have cesspool vehicles. Cesspool vehicles come in two types. First type is trailer mounted assembly. On the top right hand side, you can see a trailer mounted assembly. These trailers are usually tugged using tractors or any other heavy vehicle which can pull this trailer. The trailer mounted assembly usually has a tank which is of the capacity from 3000 liters to 4500 liters. The assembly consists of vacuum pump and other accessories which are required for the cesspool vehicle to operate. The second type is a truck mounted assembly. The chassis of the truck has all the tank as well as the other accessories which are required for the cesspool vehicle to operate. in truck mounted assembly, we can have a variant cesspool vehicles starting from 3,000 liters to up to 11,000 liters. The price range of these assemblies, they start from 5 lakh and above. But the 5 lakh is only the cost of assembly. The cost of truck or a tractor is additional. Let's take a deeper look into what are the components of cesspool vehicles. The most important component of a cesspool vehicle, which sets it apart from a normal water tanker, is the vacuum pump itself. Here at the bottom of the truck, you can see a vacuum pump, which has three main components. That is the vacuum pump, the second is the hydraulic motor, and the third is service liquid pump, service liquid or an oil pump. So all these three things are required to operate the vacuum pump. Then comes the tank and its accessories. The accessories such as the outlet pipe, or which also functions as the inlet pipe, the hatch or the door itself, which completely swings open so that during maintenance or to do something from inside, the tank can be completely opened. And then there are different accessories or safety features which protects the vacuum pump from the liquid itself. As the vacuum pump, the function of the vacuum pump or the process in which the vacuum pump works is very different as compared to a centrifugal pump. In centrifugal pump, the water, it flows through the pump, whereas in case of vacuum pump, it's the air which flows through the pump, whereas the liquid is sucked right into the tank and stored in this tank. The vacuum pump needs to be protected from solids as well as the moisture, and hence there are various safety features which are required. The cesspool vehicles, the minimum width of cesspool vehicles is 3 meters, and hence most of the time these cesspool vehicles are not appropriate for catering to septic tanks which are in the slums or communities having very narrow roads. And also the suction power of the vacuum pump allows only 100 feet of suction. And hence sometimes it is not possible that we can park the vehicle next to the septic tank and empty the septic tank. And hence there is a requirement of a smaller version of a cesspool vehicle, which is also known as vacuum tug. Vacuum tug is a trailer mounted assembly. In the picture on the left side, you can see the similar assembly which is mounted on a smaller trailer. The capacity of this tank here is 300 liters, and this tank can be pulled by humans. 2 or 3 persons are enough to pull or tug this vacuum tug. On the top of the tank, you can see the vacuum pump and the motor installed. So this vacuum pump creates suction in the tank and sucks in all the fecal matter and septage into the tank. The picture on the right shows a motorized option, wherein the motor which is used to run the vacuum pump can also be used to power the front wheels of the vacuum tug. In this case, since there is a motorized power given to the front wheel, humans don't have to tug it, and hence we can have bigger capacities of tank installed here. Typically, a 300 to 700 liter tanks can be installed on a motorized option. The function of vacuum tug, however, is only to empty the septic tank and convey the contents of the septic tank from the household to the cesspool vehicle. Since vacuum tugs, the capacity of the vacuum tugs is so small, they cannot be or should not be used for conveyance, because tugging these vehicles or even using motor to run these vacuum tugs can be quite costly, and hence they are used in between the cesspool vehicles and the septic tanks. The next functional group is treatment, where we have different kinds of treatment, natural as well as mechanized, aerobic or anaerobic process. However, due to the limitations of time, we cannot cover the treatment systems or treatment units in this session. We'll be having a different session altogether, prioritizing only treatment options. And the last functional group is reuse or disposal. Usually the treated products such as treated water in a centralized STP or the biosolids, they are disposed of. The treated water mainly goes to streams or surface water bodies, whereas the biosolids, they are usually dumped onto the land or they are taken to the landfill. However, there are several reuse options which are available. Agriculture can be one of the most important sector where the treated end products can be used. The biosolids can be very well used as compost. The water, which can be made rich in nitrates and phosphates, can also be used for fertigation. Next is aquaculture. Aquaculture is cultivation of fishes or water-based agriculture. So the treated wastewater can also be used in aquaculture. We'll be seeing one such case study in this session. There are several energy products, that is biogas or methanation, which can be done on sludge, and hence we can also get energy products. And lastly, recharge. The treated water can also be recharged into groundwater. However, it needs to be managed and monitored carefully. Hence, this technique is called managed aquifer recharge, or also known as soil aquifer treatment. You can get a lot of information regarding managed aquifer recharge and soil aquifer treatment on the internet. Now let's visualize to see how the sanitation system looks like, how these functional groups, they are interlinked to each other. On the screen, you can see a quite elaborate sort of a sanitation system. I'll explain you the sanitation system in detail. On the very first column, you can see different types of waste products. In the second column, you see an interface. In this case, since this system is describing a twin pit toilet, we have a pour flush toilet here. The output of this pour flush toilet is black water, which is diverted into a collection and storage unit, typically known as twin pit or leach pit, where the contents of this pit are converted into pit humus and needs to be emptied and conveyed, and then reused for application in agriculture. The grey water, however, has to be handled separately. The most simplest method in which grey water can be handled is to use a soak pit or a leach field. So this is how we can see how a sanitation system can be visualized. Let's take another example. Let's take an example of a non-sewered sanitation system with a septic tank included. In this case, the feces, urine, flush water, and also the anal cleansing water goes into the toilet. The toilet can be a pour flush toilet or a cistern flush toilet, which gives an output of a black water. In this case, the black water is diverted into an on-site containment system, such as a septic tank. The septic tank arrests all the solids and produces sludge, fecal sludge or septage. It also gives out liquid, which needs to be handled separately. In this case, in this system, we can see the liquid is mixed with grey water and then diverted towards a soak pit or a leach field. The sludge, which is contained in the septic tank, needs to be emptied and transported using a cesspool vehicle. Further, it needs to be treated, where we get treated effluent and biosolids, which can be then reused or disposed of separately. Now let's see how sewered sanitation system with a septic tank will look like. So it remains the same until here, but now the effluent of the septic tank and the grey water, instead of going to a soak pit or a leach field, it is now collected and conveyed using simplified sievers or solid free sievers. We need solid free sievers because now there is no solids which needs to be conveyed. Further, the wastewater which is collected and conveyed needs to be treated, and same goes with the sludge part. Hence, we see the towns where we have a lot of septic tanks and the effluent of the septic tanks is being put into the open drains or nalas, as we know or call it. They can simply design and put solid free sievers, and operate the conveyance system at a fractional cost of a gravity seaboard. Lastly, the most simple or very straightforward system is a seaward sanitation system, wherein the black water or domestic wastewater is collected and conveyed using gravity sievers, where it goes into a centralized STP and the treated wastewater is usually disposed of into the rivers and the sludge is sent to the landfill. So in this way, we can visualize different kinds of sanitation systems. It needs to be understood during sanitation planning of a city. Different wards or different regions in a city can be catered to by different sanitation systems. And it largely depends on the population density as well as the availability of the area. We'll be looking more into the applications of different sanitation systems in the next session. So in this case, whenever we are doing sanitation planning, an approach called backwards planning is really useful. So in this approach, we try to prioritize reuse. We see what are the avenues for reuse of treated water as well as biosolids in the city or in the given context. From that, we decide as to what should be the quality of the output of the treatment plant. So what should be the quality of the treated water as well as what should be the quality of the biosolids. And then depending on that, we design the complete system, that is the treatment system. And then we understand what are the inputs which are required to implement and operate and maintain these systems. So basically, what are the materials which are locally available? What is the kind of human resource or professionals or the experts which are required? What are the finances? And what sort of extra information from the ground would be required to start the planning process itself? Hence, during the preliminary surveys or during recce visit towards to the for sanitation planning, we usually start from the end of the sanitation system. Let's take a look at two case studies. Both the case studies are focused towards centralized systems. One has sewerage and STP, and the other has open drains or closed drains, and also in some parts there are sewerage, but the treatment is done in a very natural way. The first case study is that of a sewage treatment plant situated in Bhandewadi in Nagpur. This STP is the design capacity of this STP is 130 MLD and it spreads into 12.5 acres of area. It's a huge plant. It is based on a sequential batch reactor, also known as SBR process. The key element of this whole project is the treated water is supplied to a thermal power plant, which is 18 kilometers away from this STP, and it is supplied using a pipeline. Daily, the major chunk of the treated wastewater is conveyed to the thermal power plant, where it is used for processing the fly ash and used for condensation purpose. So you see here, it's not so the whole project was conceptualized by finding the right stakeholder who can reuse the treated water, and the whole system or the treatment plant and the system sanitation system was designed accordingly. Unlike this very technical or technological approach is the second case study, which is fish farms in East Kolkata wetlands. So these wetlands in the east part of Kolkata caters to almost 600 MLD of sewage on a daily basis. 600 MLD of sewage is conveyed to these wetlands using network of sewerage system and also open closed drainage systems. The wastewater, the wetlands, they spread in total of 125 square kilometer area. The wetland is situated 8.5 feet below the highest point in the city, and hence the sewage is flows under gravity. The process which is implemented here is mostly rhizofiltration. On the slide, we can see different components of these wetland systems. So the sewage, which is coming from the city, it passes through big screens. So these screens are installed in the nala itself or on the stream itself. It screens off not just the plastic waste, but also the invasive species of plant like water hyacinth. The water then is diverted to sedimentation ponds where the solids they settle down. Then these ponds, then there are a series of ponds which are used for pisciculture or for fish cultivation, starting from egg pond, nursery, rearing, stocking pond, and harvesting. Here, the brown line indicates the sludge. The rearing ponds, stocking pond, and harvesting ponds, the bottom of these ponds have sludge. This sludge is completely decomposed or degraded and hence safe for use into agriculture. After every few years, these ponds are desludged and the silt is used in agriculture. The treated water from the harvesting pond is also used in agriculture. And the fish which is harvested from these wetland systems is a good source of food for Kolkata city. However, this whole project is not although it is not very technical, but for the success of this whole project, the natural conditions were quite conducive. The natural conditions such as hot and humid climate, which is required for fish cultures, the shallow ponds or the series of shallow ponds, and the area itself. The treatment is done using photosynthesis by the plants which are grown naturally in these wetland systems. The BOD reduction happens substantially, and also due to the large hydraulic retention time, coliform reduction happens. The process here is a natural process and can be checked out in the video further. So let's take a look at the video. First, let's see the video of Bhandewadi STP.
Designed and commissioned by SMS Limited, this unique, state-of-the-art, fully automated, and one of the largest sewage reuse plants in India, spread over a sprawling 12.5 acres, takes in 130 mld of sewage water from the Nag River and cleans it as per the quality standards of a thermal power station before supplying it to Koradi. Driven by the passion to set global benchmarks in the field of environmental engineering, SMS Limited has designed this plant to harbor a range of structures and equipments that function as clockwork. The entire process is monitored in this section, housed in a dedicated administrative building. This is the nerve center of the project and houses state-of-the-art equipment and control panels. An electrical indoor 33 kV substation houses control mechanisms. The entire facility is powered by 5,000 kilowatt of energy as regulated by a powerhouse in the premises. Water from the Nag River is brought to the facility through pipeline into the intake structure, where floating material up to sizes of 6 mm is removed by fine screens. The water then passes through the mechanical detritors, which remove the sand and grit from the sewage water. After primary cleaning, the water is sent to the primary clarifiers for partially removing BOD and TSS by adding alum at partial flume location. Hydraulic retention time of 30 minutes is given at primary clarifiers for settling purpose. After passing through the primary clarifiers, the water overflows through the launder and through an underground duct passes to the CTEC basin for secondary treatment. The water from primary clarifiers now flows to 8 CTEC basins for aerobic digestion of biological impurities in the presence of the oxygen supplied by the 24 blowers, housed in 2 buildings controlled by VFDs. This primary cleaned sewage water is now subjected to sequential filling and aeration, sedimentation and decanting mode for secondary cleaning. The decanted water from CTEC now passes through the chlorine contact tank or CCT for addition of chlorine to the treated water for the treatment of balanced bacteria. Chlorine toner 1 ton tank is used to disinfect the water. The water, after processing with chlorine, is now passed to a sump from where it is shifted to tertiary treatment plant using 8 vertical turbine pumps. In TTP, water is passed through a multi-bed media filter comprising of anthracite, sand and pebbles for final cleaning to achieve the desired parameters as per the requirement of Mahagenco suitable for the thermal power station requirement. This water passes through the filter media to the under drainage system, from where it is transferred to the pumping sump by rising chambers. 8 vertical turbine pumps are used to transfer this treated water to Koradi through a 1200 millimeter diameter cross-country pipeline, approximately 18 kilometers away from Bhandewari, for cooling and ash handling system of 3660 megawatt thermal power station. The settled sludge in primary clarifiers is transferred by progressive cavity pumps for thickening and for segregation of water, and sludge after anaerobic digestion in digesters. The biogas produced during the anaerobic digestion is collected in a pair of gas holders, and from there it is sent to flares. With this ingenious project, SMS Limited.
So in this project, you saw that how the stakeholder who is going to reuse the water was identified at an early stage of the project, and also an additional treatment for the wastewater, that is a tertiary treatment step, was included at the STP itself, so that the treated water can be directly used at a thermal power plant. The rate or the cost of the treated water was also discussed with the Mahagenco, that is Maharashtra Electricity Generation Board, before the start of the project. And hence, this PPP driven model was used to set up the whole plant. Now let's see the second case study, which is on East Kolkata wetland. I couldn't find a very small video which could show the actual photographs or the actual processes, but this is a good animation which shows how the treatment happens. There are several other videos, longer videos of 40-50 minutes, which you can see on YouTube to see how the whole wetland functions.
Detoxification of waste using biological system. So it could be plants, it could be microbes. Now to tell a little more about the process of purification that is taking place in the Bheri. The raw sewage which comes in has to pass through a sieving procedure where the suspended material, the coarse suspended material is released. The water moves into a flat basin which is there, which is created in such a way that the water depth should not be more than 50 to 150 centimeter. A flat bottom which has been treated with alkali lime ensures that there's an alkaline pH, which is a must for decreasing the coliform count. Now the water, which is rich in organic content, is released there. There is a manual aeration which takes place, and because of that, the dissolved oxygen concentration is kept pretty high. Now with the sunlight penetrating till the bottom, as it's a flat surface, through and through aeration and sunlight ensures that the plankton grows there. Well, if the plankton is allowed to grow for indefinite time, it results in plankton bloom, and that's a problem, eutrophication. But that doesn't happen. So before it reaches a plankton bloom, the fishlets are released there and they consume or feed upon the plankton. So it's the initial plankton, then phytoplanktons, and the zooplanktons which consume them. Again, the phytoplankton is growing. Now the fishlets are released, which feed on the phytoplankton as well as the zooplankton. Thus, the entire organic matter in the raw sewage which came here is consumed by these planktons, and that in turn becomes the fish feed. So you do not need to actually add additional feed, whereas the water which is there is purified. When you check the quality in terms of coliform count, when you compare the raw sewage water to the water in Bheri post growth, there is a 96 to 99% decrease in the coliform count. There is immense decrease in the metal content. Now the water which is left after the fish growth is good enough to be used for irrigation.
So in these two examples which we saw just now, we saw that the ultimate aim was to treat the wastewater. But in case of Bhandewadi STP, the treated wastewater was reused at a thermal power station, and economical benefits were taken from that aspect. Also, what we saw is very less manpower was required to operate the complete plant. Since there was a centralized monitoring system or a SCADA system which was installed, 2 or 3 persons can take care of the whole operation of this STP from the central control room. However, you need professional experts to operate and run such plants. On the contrary, in the second example, we saw that how these wetlands were used by the fishermen to cultivate the fish. The wetlands were maintained completely by the community of fishermen or the villages around these wetlands. As these wetlands were a source of income for these villages, they maintained the wetlands beautifully. Also, at the same time, treating the wastewater. Also in the video we saw that the fishermen didn't need to invest into food for these fishes because the sewage itself was growing the phytoplankton which acted as a food for the fishes to grow. And hence a community driven approach was taken in this case, and daily 600 mld of water is being treated. So in a city, you can see a lot of cities have this typical wetland sort of spaces available. Unfortunately, in most of the urbanized cities, these wetlands are nowadays covered and they are used for commercial or residential developments. However, if conserved properly, they can act as a public utility space for treating wastewater also. So with this, we are ending today's session. So to summarize today's session, there are different types of sanitation systems with the same objective of protecting environmental health. Sanitation system approaches to understand the urban water cycle from the point of generation to the point of reuse and disposal. One thing which needs to be understood right from the beginning is affordability of the complete sanitation systems. It is not just about the toilets or the sewerage or the treatment plant, but it is about the complete system which takes care of this waste. The user interface plays a very important role because it determines what functional groups will come afterwards. So if you are a engineer or a company in, let's say, mountainous region like Leh or Ladakh, and you plan to put a sewerage system, it will never function because the people there are using dry sanitation or dry toilets. So we need to understand carefully as to which kind of functional groups will follow the user interface. The sanitation system approach is particularly important for wet sanitation systems because a lot of functional groups come into the picture. And also during sanitation planning, if we prioritize end use or reuse of the treated product, it eventually helps us to define the boundaries of the complete project. So thank you for today's session.
Any question regarding today's presentation or any additional reading material or any additional topic on which you would like to have for the lecture sessions? And
so since there are a lot of participants from different parts of India, I would like to know if someone has actually seen a pit latrine or a UDDT or a Ecosan toilet before, or is it just the pore flush toilets or the cistern flush toilets which are there in all of India?
Dhawal and Dipinder.
Yes, sir.
For a city, it can be a combination of systems. I mean, it can be a wetlands plus STP plus shallow sewer. It can be a combination of several systems.
So ideally, it shouldn't be the case, but in India, we have seen that most of the cities do have different systems already in place. Since the implementation of sewerage systems take a longer time, a lot of cities are actually served by sewered as well as non-sewered systems. To give an example, in Kolkata itself, there are these wetlands which take care of part of the sewage which is generated by the city, and there are also STPs which are set up by the state board who looks after the wastewater treatment plants. So there are STPs also who cater to the other part of the wastewater which is generated in the city. So essentially, none of the cities in India, I can say, are dependent on only one kind of systems, and these systems need to complement each other.
Another question is that when we talk of nature-based solutions, uh, is that a particular solution or is that including two, three solutions?
So, nature-based solution, this terminology is mostly used in the treatment when we talk about the treatment systems. In nature-based solution, for like the example which we saw, these are natural wetlands. This is not created by humans, and still they can treat the wastewater. Whereas the nature-inspired solutions like waste stabilization ponds, or the DVAT system, which has different units for anaerobic processes and for aerobic processes, or the engineered wetlands or constructed wetlands. So there are a range of options which are available. It depends on what are our boundary conditions, what are the constraints at the site, depending on which we can choose what kind of nature-based solution we can use to cater to our or to provide the solution to the city.
I have one question, Dhawal. The tiger toilet that you mentioned, is
Mhm.
it using a similar kind of a technology? Because nowadays we have seen some case studies of tiger worms being used for fecal sludge treatment. So is
Right,
this the same
right.
technology? And where in India we have such fecal sludge treatment systems?
So the tiger worms, the application of tiger worms in fecal sludge came at a later stage. The very first application was into tiger toilets, where a lot of research has taken place, and these tiger worms, they usually, as I explained, they help to degrade the fecal matter completely, and hence the solution was upscaled to a treatment plant level. As of now, I think one such fecal sludge treatment plant is set up in Kerala, I think Wayanad. It is set up by UNICEF. But I'm not sure. I don't have the technical details about the whole plant, but it's a small plant which is now set up and fully functional. It has two technologies in it. The first technology is the biodigester technology, where anaerobic decomposition of the incoming septage is taking place, and then the effluent of these biodigesters are sent to the tiger toilet technology, where the water is further treated and compost is created. These toilets, however, tiger toilets are quite popular in and around Pune. Also, we have seen a lot of tiger toilets being placed at schools or in villages, and in Bangladesh, a lot of such toilets are coming up. Tiger toilets have been recently also integrated into humanitarian solutions during the crisis, post-crisis, whenever sanitation systems need to be installed. Tiger toilet is one such kind of toilet which is used, because it doesn't take a lot of time to set up the toilet itself. So rapid deployment can happen.
One more question, Dhawan.
Yes, sir.
When you in your first slide you said that the objective of a sanitation system is to prevent human fecal contact.
Right.
So in the wetlands example, there is a fecal contact. Finally, it's the fish farmers are actually standing in it and aerating, beating.
Right. Right.
Is it recognized as a safe practice at the international level?
Well, if so, the animation was not complete depiction of how the actual processes happen. The in usual processes, these fishermen, they go in the boat, and the mechanical aeration doesn't happen where the person is standing in the water itself. However, at an international level, we cannot say that this is completely safe because there is a lot of sewage which is being used. So I wouldn't term it as safe completely. But nowadays, with more awareness regarding the kinds of diseases which spread because of touch with sewage, these fishermen have adopted to different ways of aerating and doing the operation of the wetland.
There
Hello.
was a question in the chat section
Uh,
regarding the characterization of the sewage that can be taken for like natural treatment system. So it's regarding whether if there is a chemical content in the sewage, whether it can be
mhm.
treated in wetland.
So typically the wetlands they can cater to domestic wastewater very easily. There are a lot of case studies in India where domestic wastewater has been treated successfully using wetlands. On an international level, there are examples where wetlands have been used to treat even effluent of oil and gas industry and other industries as well. And the function of wetlands in those cases is to remove the chemical content or the chemical contaminants. And hence, yes, the answer is yes, we can use wetland based or nature based system to even treat chemically polluted wastewater, but we don't have a example successful case study in India as of now. But we can share with you some international case studies which we have.
Yeah, this is Kaushik Ghosh from ATI West Bengal. So,
Welcome, sir.
yeah, I was having some audio problem, and very nice presentation, Dhawal. I really liked it.
Thank you.
I would like to add a few points regarding East Kolkata wetlands.
Yes,
The
please.
Kolkata wetlands were strategically designed to divert water through sluice gate. It is a natural setting, that is true, and that potential was harnessed by strategically diverting the waste to the East Kolkata wetlands, and it has been functioning quite well for the last so many years. But however, uh, since the leather complex and some industrial complexes sprang up, the content of heavy metal in the waste is a threat nowadays, like chromium, cadmium, zinc. So that cannot be removed through this system alone. That requires separate intervention, and that is presently threatening the agriculture and aquaculture in that region also. So this is one major threat area which can be addressed through maybe constructed wetlands or otherwise. Thank you.
Thank you so for sharing the details. Any more questions from any other participants? Because we wanted to conduct a small survey on the effectiveness of this lecture series, or else we can like begin the survey. Dhawal, can you please update regarding the next lecture series?
Yes. So in the next session, which is on liquid waste management, we are going to see basically what are the different levels of management. We are going to look into centralized and decentralized systems in a detailed manner as to what are the requirements of centralized and decentralized systems, what are the environmental benefits, what are the limitations, and how the economics of centralized and decentralized wastewater management works. So the next session is going to be on 28th of May, which is day after tomorrow. Yes, so we are going to have the session 3 on liquid waste management on 28th May from 3 p.m. to 4 p.m.
Thank you, Dhawal. Akshay, now can you please start with the survey, the Mentimeter survey?
Hi everyone. So just to collect your feedback for today's session, we're trying to use a website called Mentimeter. I'll just quickly demonstrate how it works and then maybe we can do it. So all you have to do is open this website on your browsers. It's menti.com. And this is the website. This is the page which opens up. So if all of you could just quickly do that, we'll quickly move to the questions.
So you can access the website from your phone also.
Yeah, from your phone or from your laptop, whichever is more convenient. So in the box where it says please enter the code, just enter this code, which is on the top of this slide, 576444, and you'll quickly see the question by itself. So if you could answer this question for us in the next minute, we'll just quickly wait for everyone to submit their answers and then move on to the next question.
Browser, then we can see the number of response we have received. Actually, we can move to the next question.
Okay.
Looks like everybody has answered.
Sure. So with the same code, you can now see the next question, which is this: what further support do you need on today's topic? And based on your answers to this question, we can maybe include some of the reading material or any other material which SCBP has prepared in our follow-up emails. You can also find them on our website as well. Okay, thank you for that. We just have quickly two more questions, so I'll share those questions as well. For those, you'll have to enter a new code, which is now displayed on your screens, which is 378814, and then you'll be able to see this question. So you can just refresh the page or open menti.com on a new tab and then enter the new code, and you'll see this question. Okay, and the last question is this: what support would you need for conducting similar training in your state? Thank you, everyone. Apart from these questions, also, if you have any other feedback, please feel free to email us in the invitation email, and we'll be happy to take it into consideration. Jyoti?
So after this session, Hari will be sharing a Google link feedback format also. So if you have any additional like request or queries, you can send it to us. And also the further reading materials regarding the sessions that we are conducting now have been curated from the various training modules we have. So these are like 2-day or 3-day kind of a training, but for online sessions, we have converted them into short and very comprehensive 15-20 minute presentation. So Akshay, we can show the website.
Yes.
So all our modules are available on our portal, scbp.niua.org. So you can go to training module sections. So you can find various modules regarding both wastewater management, fecal sludge management, designing of fecal sludge treatment plans. So in future, we plan to convert various modules into such short training sessions, and we hope that these videos can be used by you for conducting training in your state, or you can use these videos as a short learning videos for sharing across the ULBs in your state. So we are open to providing support to any institute who wants to take up such activities. And thank you again for joining for the session. And we look forward to meet you all in the next session on 28th. So Hari will be sharing the session details for that session for the upcoming lecture session also. So thank you. Thanks a lot.